Chapter 7, in class exercise 1, problem 1. Find the internal forces at point C. So, in this problem, we are interested to calculate normal shear and bending moment at point C. Now, what we have been given here is that the beam is being supported by a roller support at A, which only applies vertical support reaction, and pin support at B, which applies both horizontal and vertical support reactions, and uniformly distributed load of 3 kilopound per foot. So first thing we need to do is to reduce this uniformly distributed load to a point load. So this load can be replaced by a point load just by one arrow passing at 3-foot distance from A at the middle of the rectangle, and the magnitude of that load will be 3 times 6, which is 18 kilopound. Okay, and then we draw the we will draw the support reactions and solve for the unknown forces. So this is actually a solved problem from the slide. So I'll walk you through the steps for the solution for this problem. So what is given? The loading on the beam, what we need to find the internal forces at C, and what's the procedure. First, we take imaginary cut at C, and it will be easier to work with the right side of the section because there are fewer load points and no external load is applied. So we need to determine support reaction By. So we can use a free body diagram for the entire frame and solve for equation of equilibrium. So this 13 is reduced by point load 18 kilopound passing through the middle of this rectangle, which is 3 foot from A as well as from the end. Now there is vertical support reaction at A, and there are two support reactions Bx and By at A. So when we need to solve for these three unknowns, 1, 2, and 3. Now there is no horizontal force other than By, and the system is in equilibrium. That means, sorry, other than Bx, so the system is in equilibrium, so Bx is 0. Now we need to calculate By, so we can apply, so Bx is 0, that's given here from sum of forces in x direction and sum of moments at A. When we write that equation, we do not need to know the value of Ay because Ay does not result in any moment about A itself. So then there is moment because of By, and that's clockwise By times 9, so it's negative, and moment of this one, that's counterclockwise 18 times 3, and that gives us the value of vertical support reaction at B, which is 6 kilopound. Okay, and we have assumed that it's acting downward and we get the positive number, so our assumption is correct. Now the next step is draw a free body diagram of the right section, assume directions for shear, normal, and bending moment. So we take the section, like cut this from here and keep only the right side and expose the internal forces. So on right side we have vertical support reaction, and the forces are normal, shear, and bending, and this arrows are our assumption. We are assuming the directions for these three forces. Now if we get the positive number, means our assumptions are right. If we get the negative number, that means our assumptions are opposite of the correct direction. So apply equations of equilibrium to this problem and solve for the unknown forces. This is really simple. You can see that normal force is horizontal, but there is no other horizontal force here, so normal force is 0. It's not counterbalancing any force. Shear force is vertical, and we have assumed that it's going down, but the support reaction is also going down, so we get the negative number for shear force, -6. That means our shear force is actually going up. Okay, and that's the reason that this 6 kilopound is balancing this 6 kilopound, and the system is in equilibrium. And the last part is sum of moments at C. So at C we have this bending moment MC, that's clockwise, so that is negative, plus we have bending moment because of 6 kilopound about C, which is 6 times 4.5, that is also negative, so we get MC is equal to negative number. What it means that the assumption for clockwise moment at C is also not correct, it's actually counterclockwise. Okay, so for the final answer, we can say that VC is acting up and moment is counterclockwise, MC, and this force NC is 0. Okay, so this is our final answer. This is KIP, and MC is 27 kilopound multiplied by 4. Thank you.